Okay, Unit 1, Lesson 9. We're going to continue our journey with unlike fractions, but now we're going to throw that mixed fraction in there. Okay, so when we're looking at this first one right here, we have an 8 and we have a 4. How can we make this a common denominator? Well, we know that what number did these two have? Just shout it out so the microphone can pick you up. 8. That's right. So first things first is I'm going to rewrite this entire problem. Maybe. I'm going to rewrite the entire problem. And you can write this into your notebook straight. You don't have to do this in your classroom book. You can write this problem straight into your notebook so you have notes in your notebook. So I'm going to straight write this problem one more time with my new equivalent fraction. So 1 1/4 should really be 2 eighths. Yeah? Yes. All right. Now I have a subtraction problem I can deal with, right? Yes. I can take 2 from 3, that's 1. I can take 1 from 2, that's 1. Not a lot of work there. Everybody knows how I got from 4 to 8 and 1 to 2. Wave at me if you didn't get that much. Nobody's waving, we're good to go. How about over here? Can I add number 2? No. First things first is I got to come up with a common denominator. My whole numbers are not changing. 15, I like it. So 5 times 3 is 15. 1 times 3. Okay. 15 times 5. All right, now I have 6 and 8 15ths. Okay, 6 2/3 plus 4 3/4. We need to find a common denominator. Yell it out.
15, 12.
I like 12 better. So, in order for me to get from 3 to 12, I have to multiply by 4. In order for me to get from 4 to 12, I need to multiply by 3. So I want you to physically, this is kind of like your insurance policy of math, rewrite a new addition problem. 4 9/12. And make sure, because this is mixed practice, you know if you're adding or subtracting. This is your insurance policy to make sure you're doing the right problem. Okay? Now, here comes the tricky part. 8 plus 9 is?
17.
6 plus 4 is?
10.
Can I leave that like that?
No.
Why not?
Because it's improper.
It's not proper. So, how do we make it proper? We need to take a whole out of this, right?
Yeah.
So if I subtract 12 twelfths, because that's one whole out of there, right? What do I have left? 5 twelfths. But I need to do something with this.
You add it to your whole. Make that a whole.
I'm going to add it to this 10. So what is the answer to number 4?
11 and 5 is
4 1/3, 2 7/15. Yikes! Can we subtract that? Multiple reasons why that's a big fat no. We need to get a common denominator. I think 15 should be our common denominator. Holla if you think yes. Holla! Okay, so times 5, and as our insurance policy tells us, it is a good idea to rewrite the new subtraction problem. 4 5/15 take away 2 7/15. Well, here's our first problem we've run into, friends. Can I take 7 from 5? No. All right, so here's where we go back to, I think it's lesson 4 or 5. And remember what we do. We have to do this. We have to do this. We have to add another 15, yeah? So I have 20 15ths now. And now I can subtract. So 20 take away 7 is 3. Take away 2 is Dora the elephant used to eat, I like that name, used to eat 2 3/4 tons of food each month. Now she's on a diet. I love it. The elephant's on a diet. 2 3/4. And she only eats 1 7/8 tons. By how many tons was Dora's food decreased each month? Well, we need to subtract. Hey guys, focus, Kay. We need to subtract what she now eats from what she was eating in order to find out what it was decreased by. So, we need to subtract. Well, we need a common denominator of, very good, so I'm going to go times 2, and I'm going to write 2 6/8, take away 1 7/8. Can I take 7 from 6? No. So now I have to do another regrouping before I can even subtract. Plus 8 8s equals 14 8s. Now I can subtract, right? 14 take away 7 is 8s. 1 take away 1 is 0. I don't need to write it. So how many tons? 7/8 of a ton is what her diet was decreased. Let's do number 17. Daisy the elephant can reach a branch 10 5/6 feet off the ground. Leroy, the tallest elephant, can reach a branch 1 1/2 feet higher than this. How high can Leroy reach? So Leroy equals what Daisy can reach plus 1 1/2 feet more. So there's your equation. Leroy can reach what Daisy can reach plus the little bit higher. Leroy, the tallest elephant, can reach a branch that's 1 1/2 feet higher. Now, can we add this as it is? No. What do we need? Common denominator. The common denominator here that I'm seeing is that we leave 5/6, but we make this 6ths as well. So if I were to rewrite my addition problem, which is your insurance policy that you're doing it correctly, I'm all about the insurance, friends. Protect yourselves. 8/6, 11 8/6. But is that the whole answer? Huh?
No.
Why not?
Yes, it is.
I heard it. It's improper. So we need to look at this fraction right here because it's kind of breaking the rules. I know that if I take away 6/6, which is 1 whole from it, and put it into this one, right? That he can reach 12 2/6 or 12 1/3 feet. That's how high he can reach. Yes, sir. 1. Speedy, the fastest elephant, can run 25 miles, 25 1/10 miles per hour. He's not really all that fast, is he, friends? Squirt can run only 10 3/4 miles per hour. How many fewer miles can Squirt run than Speedy? So that word fewer tells me what am I going to do? Subtraction. So here is my equation. 25 1/10 take away 10 3/5. First things first, I need a common denominator. I'm going to rewrite my math problem. 25, take away 1/10. Take away 1/10. Sorry. I haven't eaten lunch yet, so sorry. 25 1/10. 10 6/10. Oh, wait a minute. What's the problem?
You have to regroup.
We can't add this, can we? So, we need to regroup. 24, and then I'm going to add 10/10. I, just for the reasons of illustration right now, am going to rewrite this math problem again. 25 11/10 take away 10 6/10. Can I subtract now? What's 11 take away 6?
5.
10 stay the same. But this isn't 25, is it? It should be. Thank you. 24. What's 24 take away 10? 14. Is this a simplified fraction? It is? Is there a relationship here between the 5 and the 10? You can do divided by 2, and get 14. I'm sorry, divided by 5. Divided by 5. Mrs. Crane, like I said, hasn't eaten lunch. Sorry. 1/2. So Squirt runs 14.5 miles per hour slower than Speedy. So I didn't do all of the problems with you, but I tried to give you a snapshot of what's going to be expected for you on Think Central. If Think Central is hard, that's okay. I need to know it's hard. So if you get the answers wrong, guess what we're going to be going over again in class tomorrow? The same thing.